So on Monday we talked about how you can actually solve a quadratic equation by factoring. Now last week we talked about factoring and how you can break something that's in standard form into the two parentheses so that it's in intercept form. Solving really just takes that one step farther. And to solve, what you're going to do is we're going to use the zero product property rule, which states if the product of two expressions, okay, those would be your parentheses, is 0, then one of the both of them must be equal to 0. Basically what this is saying is after you factor your quadratic equation, you are going to set each of your parentheses equal to 0 and actually solve for x. So if we look at example number 1, the first thing you're always supposed to check for is a greatest common factor. And this one does not have one. And notice that it's equal to 0 this time. None of our problems last week when we were factoring were equal to anything. So that is your hint that you actually need to solve this. Most people in class chose to do this one by factor by grouping. So if we start by doing a times c, 2 times 3 gives you 6. Okay. Looking for two numbers that multiply to give us 6 that also add up to our b value in the middle, 5, is going to be 2 and 3. So I'm going to rewrite the problem as 2x squared plus 2x plus 3x plus 3. And I'm going to split it down the middle. The GCF of the front half is 2x, and when I divide that out, I am left with x plus 1. The GCF of the back half is 3, and when I divide that out, I'm left with x plus 1. And so the greatest common factor of the whole problem is x plus 1. When I divide that out, I'm left with 2x plus 3 equals 0. And this is factored. Again, the additional step for solving is now I'm just going to set each parentheses equal to 0 and solve for x. X plus 1 equals 0, and so x would have to be negative 1. For this one, I would first have to subtract 3 and then divide by 2, and so my second solution is x equals negative 3/2, and the problem is solved. That is the only additional step after you get it factors. You actually solve each one. Okay. The one thing you do need to be careful of, and we'll just kind of start this one and then it would be completed the same way, is you do always need one side equal to 0. So the first thing we would do on this one is we would need to subtract the 3 so that the problem is set up like this, and then we could solve it the exact same way as we did this one. You would start by doing a times c. You would find two numbers that multiply to give you negative 42 that add up to 1 in the middle, and that ends up being 7 and negative 6. And from there, we would continue the process in the same way. The GCF of the front half is 7x, and that will leave you with 2x plus 1. The GCF of the back half is negative 3, and that will leave you with 2x plus 1 when you divide it out. And so the factored answer, excuse me, that's not right, is 2x plus 1 and 7x minus 3. And then when you set each one equal to 0, this answer comes out to be x equals negative 1/2, and this answer turns out to be x equals 3/7. Now one thing we did talk about is we talked about a special pattern. If you look at this one, first thing you always check for again is a GCF, and both of these terms are divisible by 11, so we would divide that out first. Okay. Now, when you're left with two terms like this, one thing I want you to start looking for is, are those two terms perfect squares? And most of the time they are. And if they are, we have a special factoring pattern that can save you a lot of time. Up until now, I've been having you write plus 0x in the middle, but that's really not necessary. This is a special factoring pattern called the difference of two perfect squares. And when you have the difference of two perfect squares, that can be factored quickly down into a plus b and a minus b, basically using square roots to break that up. And so when I notice that both of these will square root evenly, or are perfect squares, I draw my parentheses. The square root of x squared gives me x and x. The square root of 4 gives me 2 and 2. One of them will be positive and one of them will be negative, and the problem is factored. It's a much faster pattern, and it only works in that situation, so if you recognize it, you should use it. And therefore, my two answers would be x equals negative 2 and x equals 2. Another thing to remember, if you look at example 4, is remember, if your a value is a 1, you don't have to go through the whole factor by grouping. You can factor this the quick way, which is, what are two numbers, actually set up your parentheses first, what are two numbers that multiply to give you 36 that also add up to negative 12? We know to get x squared, our parentheses are going to start with x and x, so we can just work on that. Well, two numbers that multiply to give you 36 that also add up to negative 12 are negative 6 and negative 6. Now, when both parentheses turn out the same, you do not have to solve both because obviously they're going to be the same answer. We would just solve one of them, and x equals 6 is our only solution for this problem.